In this tutorial, we want to deal with the display of 3D mapping data, and I have created a project beforehand in the scale of 1 to 8. And you can see my 3D object in the 3D display as an SFM model, and when I go into the 2D display, I can see the paper plan. The blank paper plan where I now want to output my 3D data as a 2D view for the print output. I go back to the 3D display and have already created a user coordinate system beforehand. That is, when I rotate my object here, I have aligned a user coordinate system so that I have the front view of my object. Then I go to the model views node, right mouse button, create model view, and then I can choose which model view or segment of the model view I want to use. I'll give it a name. And must now select my user coordinate system, and then the view, whether it's the front view or the top view or the rear view. So the scale of 1 to 8 and 300 dpi is proposed because the project was set up this way. And X and Y automated like model coordinates means we carry over the model coordinates and project the object at the corresponding coordinate insertion point. We say create. I assign this view to all groups and I'm going to apply. So when I switch to the 2D display, I can now see here my model view. And I switch to the mapping tree just to see how it maps the corresponding mapping data on the object. Can now switch back and forth on the groups. And now a visualization of the corresponding mapping content takes place. And we go back to the project tree. I choose my model view and the model views node. I see my object and my tool window on the right to control the model view. And I have 4 tabs up here: model view, layout, image, extended. Let's start with the index card model view. I still have the options up here, so I can turn the object display on and off. Then I can anchor the object position. I can see the change from red to blue, which means I can't move it after I have anchored it. I could change the coordinate system again. Usually that doesn't make sense. I can change the front view or the top view. I have the option of an orthogonal display here. I can switch between a perspective or orthogonal projection. And I can think about it depending on the objects like ceramic shards or even a sculpture if perspective or orthogonal display makes sense. For a facade, I would prefer to put different facade plans side by side as an orthogonal view. Orthogonal projection is proposed here in the software by default. I can define the background color and can activate the lighting. That means we know the normal directions of the surface, and then depending on the intensity of the lighting, I can express a certain plasticity more strongly. As a rule, you are served well with a lighting of 50 to 70%. I can then control the content of the display, that is, what do I want to depict. Currently, the triangles are selected together with the texture. I could now also say here without texture and only see the standard color. Then I see here the pure triangulation with the corresponding mapping. So now when I change the mapping tree, the mapping data can only be displayed on the pure model. We go back to the project tree and I activate my texture again. When I turn off the triangles and only turn on the points, I can see the basis of my surface model. And if I go to standard color, I have the black and white picture with the corresponding front and back view. Here, that makes no sense to use. So you go back to the triangles and switch off the dots. We switch to the second card layout. And the upper area is interesting because I can later correct the display scale or can also combine model views with different scale sizes. The way it works in 3D mapping is that I load an SFM model, for example a textured surface model, true to scale into the project. And when I map in the project, the quantity survey takes place on the 3D model. And then I have the possibility for the 2D print output mapping content with the model view to scale arbitrarily in a large or small representation, and also with several views so that I can see some areas 4, 5, 6 times in the 2D display, but in the quantity survey on the 3D object, it is of course counted only once. That's why you have possibilities here that you don't have in the 2D display. And by default, it is suggesting the project settings. Then 1 to 8, 300 dpi is chosen here. If I now go to the second setting, limits, then the scaling refers to the boundaries of the selected box. And if I now choose the rectangle here in the third column, then I can draw a small window here or a very large window. And then the object is rescaled into these limits, and then we indirectly show here what the scale of the current display is. And then I can switch to user defined. I can enter any scale here. I give 1 to 10. Or I could also enter a 1-to-1 scale. And then I see a detail here. Activate in the fifth column, move 3D data in the model view. And then I have the option to correct my presentation. That is, I select a segment of my object that I want to see. And when I'm in this mode, I also have the possibility to change the scale with the mouse wheel by zooming in or out by turning the mouse wheel. And can then maybe correct my position again. And now when I switch to the mapping tree, I only see my mapping for the big detail of the head view. So in this sense, I could give different detailed displays as an extra image plan on a larger scale. We go back to the project tree and look further in the tab layout. I set my project settings again. And also activate X and Y automatically like model coordinates again and say adjust. That means the frame is automatically adjusted to the visible model area again. Here below, I still have the possibility to define a frame as a line and change a line thickness. I have the annotation of the model view. I could change it here again later, but also change the font size, as you know it from the annotation dialog. If I have now automatically enabled right value and high value up here, I can't do much with the positioning down here, but if I turn that off because I don't care about the parent coordinate system, then I can now say based on the paper area, bottom left corner in the paper plan, 5 centimeter distance from the right and 5 centimeter distance from the top. If I now have small objects, any clay shards that I want to represent in different angles, or where I maybe want to represent different objects together on one image plan, then I can make sure that they are aligned in a common layout sorted by X or Y coordinates. I activate X and Y automatically like model coordinates and go back to adjust. For the third tab, there is a project setting that allows display settings of the image layers to also be applied to the display of the model view. For this, we go to the project settings first to activate image enhancement functions. This option is normally turned off to save memory usage. We apply. And now over here, I can change the opacity for the print. So that my mapping stands out more. The fourth tab, Extended, is more about the control of the point display. That's interesting for laser scan data. We don't need that now in this case. I go back to the first tab, Model View. And we go left to the project tree and remove my model view. Right mouse button, remove model view. We go back to the node model view, right mouse button, create model unwrapping. That is 4 or 6 views from the outside are automated through the user coordinate system. If I have an object or a sculpture or a pillar, or I have a documentation of an interior, then I choose 4 or 6 on the inside, just separated from the 4 wall views and the ceiling and the ground. I must always create a user coordinate system beforehand, which defines the corresponding alignment. We choose here 6 views from the outside, assign a name, choose the corresponding user coordinate system. The scale is set by the project. We again select all mapping groups where the model view should be visible, apply. Then we automatically generate this processing of all views. We see that the bottom view doesn't make sense for this object. When I look to the left on the project tree, I see a red box under the model view node. This stands for the container, and when we create a model view unwrapping, it automatically generates a container that collects all individual views in this container. In the first step, I remove the bottom view, right mouse button, remove model view, and through the container, I have the possibility to edit all model views together in the layout. That means I have chosen a container cylinder. I also see that all model views are activated with a red frame. And I can change the shade here on the right, for example. And then I do this simultaneously for all model views. But I can also choose a model view up here, for example, the model view on the left, and could move it a little to the outside with the slide functions of the arrow keys. Now we go to the mapping tree. This takes a moment because the software has to calculate the mapping data for all model views. And now, depending on which group I choose, I see my mapping elements in a display. And now I want to generate an extra top view for the base plate down here because I don't see a lot of it like this. So we go to the 3D display, go to the project tree and choose my 3D model. I take the selection command in the 6th column and draw a rectangle here with a pressed left mouse button. So this is the selection I want to see in the model view as a top view. I go to the 3D model, right mouse button and create segment. Call it cylinder P and see on the left on the project tree the little node for the feet. With double click on the left, I can also activate the view of the feet, and maybe here I can make the mapping much easier than if I do it on the whole object. So there are 2 reasons to create segments. On the one hand, to have manageable data if you want to map on the inner side of the arm, or as in this case, the top view of the feet without the whole figure obscuring the view. And the second thought is that maybe I have a very large object in terms of the amount of data that I have to load, and I have difficulties with the memory of my graphics card. And then I can load the model reduced only as a point cloud. And you can then create subsegments via the segments and always have the option to advance the mapping segment by segment, even with a weaker graphics card. Finally, for the print output, I have to sit at a good computer where I then, of course, load all the model data to display it completely and also create the mapping data for the model views. And now go back to the node of the model views, right mouse button, create model views. Just choose my floor slab now. See if we can use the same name here. Select the user coordinate system. Select the top view here and say create model view. Add it to all groups and go to the 2D display. Then I see my plate up here. I want to push it down from the position. And go to the tab layout. That means now the right value and high value are still fixed, so I couldn't move them at all. I turn off the high value, activate the move command, and can now move it as desired. I press the shift button because I want to move it down, and now I have here the top view of my footplate. I see that it is not yet assigned to my container. I can go to the container here, can say manage container model views, and can now take my floor slab, assign it to the container, and apply. When I go to the mapping tree, depending on the model view, I see my display of the mapping data and can switch between the displays of the mapping content at the top as normal.